Welcome to the last video on the FCEditor Complete Guide series. In the Complete Guide series, I've been explaining everything you need to know about making custom Future Cup levels in FCEditor. It's time to wrap up with the last essential piece in making a level, scripting. So let's start making the levels truly come to life. Let's first understand what scripting means for Future Cop. Scripts are instructions or code that can be ran by either an actor or when the game updates. Scripts are a vital part for any level as they're responsible for events and actions that happen in the level. Scripts are responsible for many actions, such as dialogue, spawning properties, the point system in Precinct Assault, completing a level, and much more. Scripting in Future Cop contains a lot of common principles that are found in programming. If you already know how to program, then a lot of these concepts should be very familiar. However, this isn't without some of the weird features that come with Future Cop. For the editor, Future Cop scripting is converted to a visual scripting system to help keep things a little more simple. However, we'll still need to learn some basic programming principles in order to work with scripting. Before we do, however, let's get the editor load up to see where the scripting is. The editor has a panel that contains everything we need to work with scripts. We can access this panel by hitting the Open Scripting Panel button near the bottom of the toolbar. Now with the scripting panel open, let's click on a script that's listed here on the side to see what they look like. The panel will now update and we're presented with a lot of colorful boxes and strange words. So what does all this mean? The editor uses a visual scripting style that mimics actual code. The script is ran from left to right, line after line. The scripts are broken down into these small visual nodes. The first or starting node of a line is called a statement. Statement nodes are what tell the script or Future Cop to do some sort of action. They are the nodes that will actually make something happen in the level. You can tell if a node is a statement by the square brackets in the navy blue background. The nodes that are inside the statement are its parameters. All statement nodes need to be given values that will be used for the action. For example, a statement that plays a sound needs to know what kind of sound to play. Or for a statement that damages an actor, it needs to know what actor and the damage amount. Oftentimes, when passing a parameter to a statement, we'll just want to use a value. Value nodes are nodes that give direct data, whether that be a number, actor, true or false, or anything that represents a value of some kind. These are also known as literals. You can tell if a node is a value by the cyan background. Value nodes aren't the only nodes that can give data. There's another type of node called an expression node. Expressions are nodes that take data, processes them, and then gives new data back. You can think of them like equations. For example, 1 plus 1 is an expression. It takes two values, processes them, and then gives the result. The term for a node giving a value is called returning. So for example, 1 plus 1 returns 2. An expression node will have a dark green background and angled brackets. Any node that returns a value will have these angled brackets. Values have data types that are used to differentiate certain values. While there are multiple kinds of data types, the two primary are int and bool. Int, short for integer, is simply just a number. Bool, short for boolean, is a value of true or false. Values can also be stored in something called a variable. Variables are a place to store and change data. You can use the data inside a variable to get a value, or you can change what's inside to have a new value entirely. Whenever a variable is referenced, it will show as a green background with the variable name. This may seem like a lot, but let's try to put some of this into practice by making our own script. At the top of the scripting panel, there's a button for adding a new script. When we press this, a new script item will appear asking for a name. Type in a name and then select it to start editing. As a side note, if the name is mistyped, we can rename the script by right-clicking. We also have the options to delete the script if needed, and these items can be dragged around for reordering. Let's have a little fun with this script. Let's make a script that allows the red player to destroy every blue team actor if they have 200 points. Before we jump straight into making the script, let's first think of each step that needs to happen in order to make this work. Step 1, we need to test if the red player has 200 points. Step 2, we need to destroy all actors that are on the blue team. 3, we need to play the sound telling the player it worked. 4, we need to remove 200 points from the player. And 5, we need to play a sound if the player doesn't have 200 points. Alright, now with the steps laid out, we can start making the script. First, we need to test if the player has 200 points. So, how do we do that? Well, there's a very specific statement designed to do just that. It's called an if statement. If statements are essential for many scripts, as it allows you to run a section of code only if the given condition is true. And that's exactly what we need, so let's add it. The lower area of the scripting view is where we can find and drag nodes onto our script. The if statement is in the Systems tab, which is already selected, so let's click and drag it onto our code. There's no other nodes here, so we'll just need to add it to the empty line. Now we have an empty if statement with a parameter of false. A statement cannot have nothing passed to it, so when adding a new statement, it will default to giving its value 0. We need to replace this false with our own condition testing if the red player has 200 points. But what exactly is the red player's points? Well, it's a place where a value is stored and change, which means red points is a variable. We can find this node in the Variable tab titled getVariable. Let's drag it and put it into our if statement. As you can see, it replaced our false value and put a green node that just says none, but this is because we haven't told the node what variable to get. We can do that by clicking on it. A variable selector view will pop up asking what variable it should be. There are different kinds of variables, but don't worry about that right now. Just select the red points variable. Now that we have the value of red points, we need to check if that value has 200 points. This is where we need an expression node that takes the variable and a value of 200 and returns the result. We can find these nodes under the Logic tab. There are multiple methods that we could use to see if red points has 200 points, but I will be using the greater than or equal to expression. Click and drag the expression onto the variable node, and there we go. Once added, it will have the right side default to 0, so we just need to change it to 200. Now we have an if statement that says if red points is greater than or equal to 200, do nothing. Let's add the script to destroy all blue actors. The node that we need is located in the Functions tab. These nodes will run a select function or action that are predefined by FutureCop. Because we are trying to do something with an actor, we need to use an actor function node. Click and drag the actor function and put it inside the if statement. Notice how the node is indented when inside the if statement. There are 3 parameters that an actor function needs. First, it needs to know what actor to run the function on. When pressing the first parameter, it will bring up a view to select the actor. But it also gives a couple other options too. Along with the actor option, it gives the option for group and team. Actor functions can be ran on multiple actors using a group or team rather than a single actor. As you can imagine, it would be an absolute pain to add an actor function for every possible blue team actor. But luckily, we have the option to run this function on all blue team actors. So we'll just need to hit the Team tab and select the blue team. For the second parameter, we need to choose what kind of function that will be ran on the actor. There's a lot of options here, but the one we want is called hurt. This function will hurt the actor for a certain amount, but if we give it a value of 0, it will destroy the actor immediately. Our third parameter is already 0, so we can just leave that alone. The next step is to play the sound indicating that the red player had enough points. To do this, we need to use a different kind of function node called a system function. A system function is an action that affects the entire game and not just a specific actor or nav mesh. This node contains a function that plays a sound on the level, which is exactly what we need. Grab the node and put it below the actor function. Like with the actor function, there's a dropdown to choose the function. There's only 2 options here, so we'll just choose play sound. Now for the next parameter, we'll just need to click on it and select the sound to play. The script can now destroy the actors and play the claim sound, but it doesn't remove any points, so let's fix that. What we need to do is remove 200 from red points. Remember that red points is a variable, so we'll need to change the data stored in the variable. We can find the node for modifying variables in the Variable tab. We could just use a set variable node and subtract 200 from red points, but there's a node designed to do just that. The subtract set variable node will subtract a certain amount from its current value and set it to the variable. So let's drag this to our script, select the variable, type 200, and there we go. Now for the last step, we need to have our script play a sound if the player doesn't have enough points. So we need to use a system function again, but where do we put it? If we put it inside the if statement, it will only play if the player has 200 points, which we don't want. But if we put it outside the if statement, it will play the sound no matter what. We could make a completely new if statement testing if red points is less than 200, but there's a much better way of doing this. In the Systems tab, there's a statement titled Else. Else statements will only run when the if statement's condition is false. In this case, we have an if statement that tests if the red points is greater than or equal to 200. If that is ever false, then we know that the player does not have 200 points. This makes an else statement the perfect option. To add the else statement, drag the node into the if statement. Now whatever code we put into the else statement will only run if the player has less than 200 points. So all that's left is to put the system function inside the else statement and select the sound. And here's our created script. Let's attach it to a trigger so it can be ran in the level. Create the new trigger actor, configure it, and then select the script in the scripting section. Time to give our script a test. In game now, I have 200 points, so let's see if this actually works.
Forever. Base turret destroyed. I'll see you in hell. Blue base turret destroyed.
I have less than 200 points, so let's see if the else statement works.
Blue base turret destroyed. Enemy within blue base.
Our script works perfectly. Now you might think our script is finished, which technically it is, but there's one last thing we can do, and that's add a comment. Comments can be super helpful for scripts as they can be used to describe what the script does, or anything else that might be helpful to know. Above all the visual scripting is a bar with a speech bubble icon. If we click on the speech bubble icon, it will open up a small text editor where we can type in our comment. Now that we made the comment, click on the speech icon again to close the view. The top bar will now have a shortened preview of the comment we just made. The nature of programming and scripting can be pretty complicated at times. Scripting is very open-ended, so just play around with it and see what works and what doesn't. It may take some time to understand, so if you have any questions, don't hesitate to ask. The best way to get help is to join the FutureCop Discord linked in the description. Also linked will be the scripting documentation explaining what all script nodes do in detail. We've only lightly touched on a few concepts, so for the rest of the video, I'll be explaining everything else we need to know. As we saw in making our script, there are multiple kinds of variables. When getting a variable, we are given the options for global, system, timer, and user variables. Going through each option, global variables are variables that are predefined by FutureCop, and they can be accessed and changed by anything. These variables can be changed by a script, as well as changed by FutureCop directly, which oftentimes they are. These variables should only be used for their intended use. The System tab contains one variable, and this variable returns the amount of frames rendered since level load. This variable is read-only, meaning it cannot be changed by a script. Timer variables are a little strange, but they are variables that will decrement every frame if their value is greater than 0. What this means is if a timer variable's value is set to something that is higher than 0, every frame it will remove 1 from the number until it reaches 0. FutureCop is responsible for the value decrementing, but other than that, this value is only modified in scripts. And the last are user variables. These are by far the most important variables because these are your variables. FutureCop does not touch user variables, and it's the level scripting that defines and uses these variables. Because this is an existing level, there are already going to be a lot of user variables. We can adjust and customize these variables by hitting the Variables tab on the scripting panel. The visual scripting view will be replaced by a new view showing all the variables used by FutureCop and the level. A variable will show its name, data type, and a description for what it's used for. For user variables, this data can be modified just by clicking on a field, and new ones can be added by hitting the plus button on the header. Global and system variables, however, cannot have this data modified as they are predefined by FutureCop. Timer variables are also predefined, but they can have their names and descriptions changed. To go back to viewing scripts again, hit the Script tab in the top left. Something we quickly touched on were actor functions. As mentioned, these are actions that can be ran on actors. When creating an actor function, it needs to know the actor and what function to run, but only certain functions can be selected for certain types of actors. In the last video, we talked about behavior types for actors. Along with behaviors having unique properties, they also have unique functions. Take for example the change camera function, which will change the player's camera angle. This function is only ever used by the player, so if an actor isn't of behavior type player, it won't show up. This also applies for the group and team options. The group option refers to script groups located in the entity behavior. Script groups are an identifier used to group actors together specifically for scripting. To see existing script groups, switch to Actor Edit Mode and open the Supporting Actor Data panel, then hit the Script Group tab. Here, we can see each script group with their names and common behavior type. The editor will search each actor in a script group and find the furthest inherited type that all actors share. Going back to scripting, the common behavior type found in a script group is what determines which function it will show. This also applies to the team option as well. The scripts we've been viewing are the ones used by actor callbacks, but there's actually another kind of script called update scripts. These are scripts that can be ran every update or tick if the given run condition is true. Update scripts allows us to run a script without having to trigger it with an actor. To view update scripts, hit the Update tab in the top left. The list view will show the update scripts instead of the normal scripts, and when selecting an update script, everything seems mostly the same. However, we're presented with a new header and a new node titled Run. The Run data header allows us to set how many times the script will run and the delay between runs. The repeat count is how many times the script can be executed before being disabled. By default, this value is disabled, meaning it will run indefinitely, but we can enable this value by hitting the toggle. A count is only removed if the script's run condition is met, which I'll explain in a moment. Cooldown ticks is the delay in updates or ticks in between the script running. There are about 60 ticks in a second, so this is a way to delay the script from running. Now for the node titled Run, this is the script's run condition. Think of the run statement as a required if statement for update scripts. It will only run the code if the given condition is true. As mentioned, if the run condition is met, it will remove 1 from repeat count. And there we have it. We've learned level modeling, texturing, shading, managing assets, actors, navigation meshes, and now scripting, which is everything you need to know about making custom Future Cop levels in FCEditor. There is a lot to know about the editor, so if you have any questions or would like to see more Future Cop, consider joining the Discord link below. Thank you guys so much for following the editor, and if you've managed to watch all these videos, thank you. I hope you enjoyed the editor, and as always, let me know what you think.